So now that you've had a little bit of experience using both C++ and Replit, we're going to expand on that in Chapter 3 with formatted output, and we're going to see just a couple of little bits and bobs here on how to make your interactions with Replit more smooth and streamlined. So up here at the top, you'll notice that I am not signed in. I am actually just using an anonymous rappel here. So it gets these funny, weird, it's always 3 randomly generated words. So this is bubbly, naughty bases, I guess. The advantage to me doing this here, as opposed to using one of, really where my code is located, is that for any and all of the changes that I make, it doesn't impact you guys later on. So it is still absolutely my suggestion that you use a sign-on so that you actually sign up for the service for Replit, because that way if something happens to this window, it closes for whatever reason. Actually, this is the second time I'm recording this because that's exactly what happened to me. You don't have to worry about losing all of your work and your forward progress there. So we're going to start at the top and we're going to work our way down. Up here, you'll notice we've included, again, IO stream. That's because we want this window here to work. Without that, we don't get input, we don't get output. You'll notice that we've included here using namespace std. Remember from Chapter 2, technically speaking, you do not have to do this, but if you did not include, well, it's not include actually, if you did not, I'm failing to find another word that says include, but it's not this kind of include. But if you did not use namespace std, these cout statements or any of your cin statements or any of, there's a host of other statements that you'd have to include std : with. This makes your life typing a bunch easier. There's probably a Reddit thread out there or a Stack Exchange community out there someplace that would tell you the tremendously important reason why you would not want to include namespace or using namespace std in there. And frankly, for what we're doing, they're wrong. Within the scope of the projects that we are creating, this does not harm you in any way, shape, or form. And as a matter of fact, it makes your life coding easier. And we're here to make it easy as opposed to more difficult. This up here, line number 2, include string. If we were doing any kinds of string manipulations, we would need to include that. Remember that here, an integer is a cardinal data type. That means it is baked in to C++. If we had doubles or floating point numbers or characters, those are baked into C++. Strings, on the other hand, are not always a part of the standard library. So in this version, actually it depends. So we are using, that's right up here, it's telling you Clang version 7, blah, 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 blah. So this is running inside of an Ubuntu virtual machine. This particular version of C++, actually there are some basic string operations baked in, but I suggest to you always include string because it's going to make your life easier if you are working with strings. So like here on line 18, we are working with strings. These are strings, heading 1, heading 2, heading 3. Those are strings. This line is a requirement here. Include IO manip. This is the whole of Chapter 3, essentially. Without that inclusion, we could not do things like set with, which is the whole point. Record. Moving down from there, you'll notice we have right here on lines 13 and 14, additionally here on lines 16 and 18, we have our declarations. This is where we are telling both the system and the next developer in the chain that, hey, look, these are the variables that we're going to use, and if possible, we can make what's known as an assignment up here too. So an assignment is saying that the value of int1 is going to be 1. The value of int2 is going to be 2. The value of heading 4 is going to be here inside of those double quotes, heading 4. It's not always possible that you are going to be able to do both a declaration and an assignment in such close proximity. There are going to be times where, for example, you're going to get int1 from the user. So we would make that assignment down here someplace in the greater code block someplace. But where it's possible for you to put here at the very top your declarations and your assignments, go ahead and do that. Now, what I'll tell you is, I'm just going to get rid of some of that white space in there. What I'll tell you is, it's possible that we could separate this line 16 and 17 here and place them elsewhere. It just depends on where it is in the code you are going to use these variables. But it's absolutely positively the preference of developers that you put or at least your variable declarations up here on top if you can. And if you can, you'll see that you would prefer also to put up here where you do your declarations, where it's possible, the assignment. So this is an assignment right here. The reason for that being, later on, when you have to come through your code to locate an error, so you're coming through to do bug fixing, and you're like, okay, up here are going to be located all of my integer variable declarations. But somewhere way down here, for reasons only known to you at the time you were developing, you have an int6. But the developer who came after you, the next developer in the chain who has to come through and look at your code, was not there when you were developing, lines 13 through 36. So they don't know that you have an int6 that is being, declared or used or running through here. So what that's going to do is really drastically increase the amount of time it takes for them to locate and fix that bug. So is it true that technically speaking, I could have a variable declaration way down here? Yes, but it's in your best interest and the best interest of the next developer in the chain for you to put those variable declarations up here. And again, if you can, hey, look, I know that heading 1 is going to be heading 1. Put that declaration and assignment right up here. Now, do also remember that I could say something like here on line 13, int1 equals 1, int2 equals 2, like this, and I could combine my declaration and assignment in one tidy little line with commas to separate them. That's entirely possible. It's one way to do it. I've just chosen to do it this way, so I'll stick to that convention here on my integers and here on my string declarations. So here again is another comma separated list, this time of string variables that we want to be able to use in the execution of our program. So here on line 19, this is a statement that will run, but this is also a statement to you, is that formatting output helps the user see what's going on. What I will tell you is one of your core functions as a developer is to develop a program that meets the user's needs as opposed to forcing the user to meet your program's needs. So the whole point of this is to see this. On line number 21, this output from 22 and 23 is hot garbage. And if we look over here, we can see this is not going to work for a user. So if I simply vomited into the output stream, heading 1, heading 2, heading 3, heading 4, heading 5, and int 1, 2, 3, 4, and 5, this is what it would look like. Heading, space, 1 heading, 2 heading, 3 heading, 4 heading, and 5. So 4 heading makes it sound like you're planting your head onto your desk. 5, what the heck is this doing over here? This is heading, but what the heck is that? And all of that evidently leads the user to believe that 12,345 is important. And that is not true. This output that you developed, in this case I developed, is bad. This is a little bit better because at the very least on the bottom, and what I have here, this code block from 25 to 27 is this piece right here. At the very least, 1, 2, 3, 4, and 5 look like they are separate integer, values. So that's a little bit better. But here again, heading, 1 heading, 2 heading, 3 heading. That's no good. But here in the output window, you'll notice we have a bit of black space here. It's the same as white space, only this is black. They're the same. Over here, we've got a bit of black space here. That's something that you, the developer, have to include. You'll remember that we have these escape sequences from chapter 2. The \n is a new line escape character. New line, new line, new line. And then this is garbage. So that's right there. New line, new line, new line. This is better. That one's right here. The next thing you'll notice is we've got these \t's in there too. What that provides us with is a tab. You'll notice that here, 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 and here. So that already is a little bit of formatted output. That provides a little bit of, a nicer layout for the user. And it's not all the way there. Really, what we're relying on here in chapter 3 for the most part, honestly, is going to be the idea of set width and left and right. So I need to adjust this window just a little bit so we can see what these would look like. This block right here, it's not right as in correct, it's just that these are oriented on the right. This block, you'll notice we have, in our cout statement, we have a set width of 25. Whatever goes inside of those parentheses is how many characters wide that set width is going to be. So this area from the immediate right of the E in 1 all the way to the left here to the very, very beginning of this new line is 25 characters. So heading 1, set width 25. Heading 2, set width 25. Heading 3, set width 25. You'll notice I had to repeat those set widths in here. Every time it is you want to make that area with a set width, you'll have to include in the output stream. So this whole thing is the output stream from line 30 to the end of line 30 here. All of this you'll need to include as many of those set widths as you expect to have. So 1, 2, 3, 4, and 5 of them. So you'll notice I've got heading 1, 1, heading 2, 2, heading 3, 3, heading 4, 4, heading 5, 5. That looks pretty good, right? If this was an Excel spreadsheet, that would look pretty good. That is what the user is accustomed to seeing. That is what you would have to provide. So think about things like printing a receipt. Think about things like printing a like an invoice page or anything. All of those considerations that were made in, where are these oriented? How is the adjustment here? Where is a heading? How do I, as a user, just know what pieces of data belong to what headings? All of those concerns are your concerns as a developer. Down here, from lines 33 to 35, these two lines are adjusted to the left. So here you'll notice we've got our set width again. So these breaks are still 25 characters from here over, but instead of all of our characters leading up to the right-hand side, from here they start at the left and work their way over. So the justification on this left or the justification right is implied, is up to you. But this line, or these two lines rather, here are what it looks like when we have left justified. Now you can mix and match these. So I could have this, the headings line of outputs could be justified left and the integer line of outputs be justified right, but that's not going to fix everything. What you'll notice is this extra 13 or so characters is all the way where that number 2 is going, or very nearly where this number 2 is going to be. So if I said that this block of code right here on line 34 was right justified, and this code on line 35 was left justified, that's going to look terrible. There are going to be times where you are going to have to use your calibrated eyeball to look at this and say, okay, which one of these is better? Is it going to be the left justified, or is it going to be the right justified? And that answer here, I argue, is right justified. This makes sense to anybody who's looking at this, for anybody who's seen an Excel spreadsheet, for anybody who's ever bought a product and has seen a receipt. That looks right. There are going to be times, however, where you're going to need to left justify something to make it look right. And just be aware that you can do that here. There's 2 more things I want you to know about the environment and coding in general while we have you. So now that we've seen formatted output, let's just talk about the environment here for just a moment. You'll notice that I have white space in my code. Line number 12, there's nothing. 15, 18, 20, 24. This is perfect time for it to reload. There we go. 28, 32. Those lines of white space are not there for the environment. Those lines of white space are not there to be seen here in the output window. As a matter of fact, they are not seen there in the output window. These white spaces are there for you as a developer, and they're there for the next developer in the chain. We have been taught as readers that when we go from one paragraph to another, there's that break, right? And in older textbooks, for sure. So if you were to go to the library and look at a dictionary, if you were to look at an encyclopedia, for sure, those stick to a full line break in between paragraphs. Your brains have been taught to think that way. So it's convenient for you if you set up your code this way, that these make essentially little code blocks. So it's not the same as using an opening and a closing brace. We'll see that actually not next section, but the section after that when we talk about code blocks. But these are just groupings of code that go together. So here I have my string declarations and my string assignments. Here I have my integer declarations and my integer assignments. Here I have a group of output that we can see over here. Here I have a group of output that I can see here in my output window. These blocks of white space are there for you to be able to go back later on, or for the next developer in the chain. So I'm going to be the first next developer in the chain to see your code. But in a production environment, there may be dozens of other developers that come through here later on to see your code. This makes it more clean. This makes it easier to read, easier to follow, and reduces the amount of time it takes you to locate a bug later on. The other thing I wanted to tell you about is commenting out of code. So here, lines 9 through 12 are commented lines. You can see here at the beginning of the line, we have these 2 forward slashes. So if I came here to line 13 and put 2 forward slashes in, you'll notice that immediately that line goes gray. And if I get rid of those 2 forward slashes, immediately that line comes back into play. A commented line of code, the environment and the compiler know that they are there, but they do not execute on those lines. Those are there for you and the next developer in the chain. So up here I have a little note to us on line number 3. Don't forget this new include. I put that there so that you could see these when you are looking through the lines of code. I put these lines, 9 through 11, here so that you could read these when you are going through and executing on this code. So good code, especially in a production environment, has before at least every function. So like right here, line 12, I'm going to add another piece of whitespace because I'm going to change the way that this is going to look. I'm going to say int declarations, just like so. Here, I'm going to do it again. I'm going to include a comment, and I'm going to say string declarations. So that's there. I'll finish the word. That's commenting out. One of the things I know that you as beginning developers are going to do is when you make a mistake, invariably you're going to make mistakes. Even this little 39-line block of code, when I was putting it together, I made a mistake. I actually misspelled. I can tell you exactly where it is. It was line 25 before, so it has to be this one now. I misspelled one of these two C-outs. I said C-U-O-T, and it gave me errors over here. I can actually recreate what that would say, just like so. And if I say run, it's going to tell me that there's an error right there. While we're here, it says main.cpp line 23 at character 1, error. Use of undeclared identifier. Cout does not mean, did you mean cout? Yes, I did. So these errors actually go a long way towards telling you what was wrong. So here it says the file it was located in, the line it was located on, 23, and the identifier was already at character starting at 1. So it's at the very beginning of line number 23. I can see there's my error, and if I run it again, my error will go away. So rather than deleting out that line and starting from scratch, I know that's what most beginning developers do. If you think that there's an area where there's an issue, rather than going and killing a whole line of code or several lines of code, my suggestion to you is instead comment them out first. Because if you comment them out and I run this, you'll notice that they're gone. They simply do not show up. But if I decide later on, oh, maybe those weren't in error, I can come back through here and put them back in. Now, the way I did this on either one line or several lines, so if I just wanted one line to be commented out, I would just put my cursor any place in that line, so right here in the middle of line 21. Since I'm on a Mac, it's command /, but if you're on a PC, it's control /. And what that's going to do is either comment out or comment back in that entire line of code. If I highlight several lines and comment them, so it's the same thing, either command / or control /, that's going to comment out an entire block of code. And here, if I just do it again, so control / or command /, I can comment them back in. What I'll tell you is I have seen probably by now, and this is not an exaggeration, hundreds of times. I have watched hundreds of students go, well, there's something wrong here, and delete 5, 8, 10, 12 lines of code. And what I can tell you is, you know what the mistake in that really was? 5, 6, 7, 8 characters of a mistake. It was, C-U-O-U-T instead of C-O-U-T was the issue. It was declaring an integer instead of a floating point number. Those are only characters worth of mistakes as opposed to lines worth of, replacing and removing and having to retype all of that code. When you guys reach out with questions, when you guys reach out and we connect either via, me sending you back a replit or me sending you back a video or us doing, a Zoom or a Hangouts meet or whatever it happens to be, you're going to identify for me what you were doing. And then invariably I get, yeah, but I deleted that a long time ago. Don't do that first. Just comment the stuff out. Later on, if everything's working and you're like, oh, I actually fixed it, this is great, then you can go back and delete all the stuff you commented out. That only takes a fraction of a second. But for you to go through and cut out, a half a dozen lines of code, that takes minutes to replicate. And literally, it may probably have only been 3 or 5 or 7 characters worth of a mistake. So please take my advice here. Comment out lines of code before you delete them.